Hi, I am RK. We are going to do logistic regression. I'll open an Excel sheet, new sheet. So I'll give the title logistic regression. And then I'll have the intercept. What is intercept? Intercept is that when all the variables are removed, what will be the output? That is called intercept. I'll call this as a B0. And then for each coefficient, we'll find out the slope. That will be B1, B2, B3, B4 and B5. That means I am having 5 variables. First I will take it as age. It will be a numerical value. This is a numerical data. Right? And then B2 is gender. This is a nominal data. And then B3 is BP value. It will have 3 values: low, high or medium. And then cholesterol also we will have low, high or medium. And then obesity also we will have low, high or medium. Right? Obesity, cholesterol, right? And BP. And then based on this we are going to take a decision. So I will take a decision based on these conditions. Okay. So I will take this center. Okay. Now I will have to have the data. First I will put a serial number. So I will have 1, 2, and then I will go up to say 1000 data. So I will go up to 500 data. Not 1000 data. Then age. I will put age. So age is equal to, I will take people from age 20 to 85. I will put equal to RAND, rand between tab 20 to 85 empty. I will double click it so it will cover for the entire data. And then what I will do is I will have the values for the observation. So that is high blood pressure or low blood pressure. And now that we have filled up the age, we will fill up the other data also. Right? So age, blood pressure, cholesterol, obesity, we have filled up. For these values, what will be the possibility of heart failure? That is the observation. So observed value of heart failure also we have plotted here. Right? So now we will have to find out the logit function, odd function, then prediction, matching prediction, and then maximizing the likelihoods, and then prediction, accuracy, precision, recall, and then true positive, false positive. All these things we will calculate now. Right? Before that, we will convert this high, medium or low into ordinal values. If it is high, I will take it as 1. If it is medium, I will take it as 0.5. If it is low, I will take it as 0 here. That is what I have done it in sheet 2 using your calculations. See here, I put a condition. If it is high, the value will be 1. If it is medium, value will be 0.5. Otherwise, it will be 0 here. Right? Okay. We will first calculate logit function. Logit. That is equal to B0 plus B1x1 plus B2x2 plus B3x3 plus B4x4 plus B5x5. Therefore, I will have to give the values for B0 and so I will make it as 0.5 here. And then I will make it as 0, 0, 0, 0, 0. So this is equal to B0. I will make it as F4 plus sum product of B1 to X1. I will make it as F4. So that absolute values, comma, is B7 to F7. Close. I get a value. You know, because coefficients are 0, we get 0.5. If I make it as 0.2, I will get a different value. Right? So I will click this. So it is calculating for all the rows. Now we will have to find out odd function. What is odd? Odd is equal to exponential of logit function. Exponential of this. So this again I'll double click, I'll get the values. From odd we will get the p value, the probability value. P is equal to odd divided by 1 plus odd. So odd divided by open bracket 1 plus the same value. So this again I will double click. Now I will find the p match. What do you mean by p match? Here we have observed it as 0. So I have to get p matching as 1 minus of. This is for probability for y is equal to 1. Therefore p match I will have to get p match is equal to if this is equal to 1 comma p, otherwise 1 minus p, close. So this again I will double click. So you can see here observed value is 0 means so 1 minus the p value is taken, right? So I have to maximize this p max. How do I maximize p max? The product of all the pm values should be maximized. But that is not possible because if you multiply 2 or 3 terms, no, you will get 0.000 and all, and computer will have a floating point limitation will be there. Therefore what we will do is we will find log likelihood. Log likelihood. That means maximizing the product is equal to maximizing the summation of log of this product. Log of AB is equal to log A plus log B. Therefore log of PM we have to maximize. So I will find out here ln of this value. So minus value. I will double click. I will get for all the values. Now here I will put summation, right? So what I will do is here I will put sum of maximum likelihood. So that is equal to, I will make it as auto sum. Auto sum, here I will take, right, and enter. So you can see this value here, minus 298. Now I have to find out this B0, B1, B2, 3 so that this is maximum value. Therefore I will solve it using solver. So I will go to data, solver. So I have to maximize what value? L2 value. So that is L2 only. I have to maximize using by changing these parameters B0 to B05. So I'll put, so I'll uncheck this. There is nothing but non-negative is allowed here. So I'll solve it. You can see here it has solved. Thus minus 298 is changed to minus 133 and the coefficients are obtained. So with these coefficients the p values are obtained here, right? Now I will have to find out the prediction value, right? What is prediction? I will make it as prediction. Prediction is equal to, if this p value is greater than the cutoff value, then this is equal to 1, otherwise 0, right? That is what we are going to predict here. So I will put a condition. I will make a cutoff value here. So I will put a cutoff value. Cutoff value is CUT OF of is equal to 0.5 I will put. Later on we will fix any other value. So equal to, if this p value, calculated p value is greater than cutoff value, comma 1, otherwise 0, right? So we have predicted. Now we will have to match this observed value and predicted value. So for that what I will do is I will name this, Control Shift. I will name it as, define a name as P actual. Now I will put it as actual, actual decision, actual Y, right? And then this prediction I will call it as a prediction only. Prediction, that's all. It is already given prediction. So now I will write here prediction, and then here I will give actual, then I will make it as 0. Very important here, you put 0 first and then 1 next. Don't interchange it because then it will be difficult for you to follow, and then redo it by yourself, right? So now I have to count how many of them are matching. This one and this one are matching. How many of them 0 and 1 are matching? I am going to fill it. So equal to count if yes, and I'll put actual is equal to, actual is there now, there is coming actual tab, comma, that is equal to this is P6, right? P6, therefore I'll put comma, prediction is there now, prediction is there, should be there, prediction is there, tab, comma, that should be equal to this F4, close it, you will get this value, 113 values, right? What I will do is, I will copy this here, I will have to make it as P7 here, because that should be 1, right? And then I will copy these two, here I will have to make it as P6 is and R6, R5 here, again R5 here, right? I will find out the addition here, home, auto sum, enter, here also enter here. So what I will do is, I will have to make a change, here it is P7, not P7, Q6, it is Q6, that 0 should not be added. Here again, now I will just copy it, right? Similarly here, auto sum, that 0 should not be added, right? And then I will copy it here, and then I will auto sum here, so it will have tally 500, right? Now I will find out accuracy, precision and recall, precision and recall. Accuracy is there. What is accuracy is, out of the total 500, we have correctly predicted the actual as actual, and that is 0 as 0 and 1 as 1 here. So equal to this, therefore I will put plus this, therefore I will put divided by 500. So I will put a close open bracket here, so it will be alright. Right? This is right here. Accuracy is 0.634. I will make it as here also. Precision is equal to, see, total predicted as correct is 220. Out of this, actual is 204 only, 1. That is called precision, equal to this divided by this. I will make it as F4. Make it as F4. So enter 0.92. And recall is, see, total actual is 1, out of which we have predicted correctly 204. Therefore is equal to this divided by 371. Make it as 374. So 0.54. So now what we will do is, we will calculate the accuracy, precision, recall for various cutoff values. Cutoff value 0.5, this is. If I take a different cutoff value, what will be the precision, accuracy? So what I will make is, I will make it as accuracy, precision, Control C, change this as paste it as transpose. So transpose paste, so it is called here. Now is equal to 0.64 F4. This is equal to 0.92 F4, and this is equal to 0.3 F4. Okay. So cutoff value, I will vary it from 0.1 to 0.9. So I will select this data, and then I will go to data, what if analysis, data table I have to select. What is the input value? That is cutoff value, column input. Therefore I select column input, and then I'll say OK, it is fixing for all, right? This also it should come, I think I will not put it. Now I will plot this. I will plot this parameter, right? Insert, scatter plot. This is how it is plotted here. Why is it same here? So I have to make this K7 fixed here, F4. Then I have to, so then only it will change here. See here, because I have not fixed this, because everything will have to be checked with cutoff value. Cutoff value is changed here, cutoff value is checked here. Now you can see this graph. Please here, accuracy and precision are same. Recall is very high. Everything should be very high, that only very good. But here, precision is increasing, but at the cost of accuracy and recall. Therefore, I will fix it as 0.5 is the best value here. Right? All are good. Or I can go for this here. Here accuracy is, precision is same. And then recall also is very high. Therefore, 0.4 is best value. So I can go for 0.4. That is what I have gone, no? So 0.4 is there. Right? If you want, I can go to 0.5. Right? Then this changes here. 0.93, it has come down. Right? And it is 0.90. If I make it as 0.4, this 0.90 has come down. See, 3% comes down. Right? Therefore, I would prefer 0.5 if you want more accuracy, precision. Right? If you want more precision, 0.90. Otherwise, so you can refer this depending upon what you want, you can select this. Now there are two values called true positive and false positive. True positive and false positive. We'll plot that also. What is true positive? We'll see here. So this also I'll make it as so here. True positive is equal to, see, actual positive is 371, 1. And we have predicted correctly 1 as 347. So the 47 divided by 371. That is true positive. Same as recall. False positive is, actual false is 129, but we have predicted as positive. Therefore, false positive is 38 by equal to, 38 by 129. This is true positive, false positive. We will make a plot of true positive and false positive also, right? So what we will do is FP, TP, right? So equal to this 0.29, I'll make it as F4. And true positive is equal to 0.9351. I'll make it as F4. Okay. Now again I will cutoff values, I will vary 0.1 to 0.9. Control. So I will use data table and fill up this table. So I will select what if now. Data, what if analysis, and then I have to vary this input cell, that is cutoff, and then OK. So it has filled up. Now I will plot this FP versus TP. Insert. I will select this only. Insert. Recommended chart. This is the one. Now I select this. Bound 0.7. And this make it as 0 here. So false positive means you are making a mistake. True positive means I am making the right choice. So TP should be high and FP should be low. False positive should be low here. So if I reduce it to 0.2, I am having 0.9 here, true positive. And if I reduce it further, I reduce true positive also, which I don't want. Therefore, I will fix it here. So 0.2, I will 0.2 and 0.9 I will fix here. See what is false positive 0.2. 0.2 is here, somewhere here. So 0.6, 0.2 here. 0.5 is okay. 0.2 and 0.95, right? 0.95 is this, that is here. This is corresponding to a cutoff value of 0.4, right? So in between these two. So I have selected 0.4 as the correct cutoff value, and this chart is called ROC chart or ROC curve. We will see. What is ROC curve? Receivers operating characteristic curve. That is what is this. From this we are maximizing the true positive and then minimizing the false positive and fixing the corresponding cutoff value. Right? So you maximize TP, minimize FP and find the cutoff value, and that is close to 0.4 to 0.5. So we have fixed 0.4, and now we can predict the values. So given the characteristics, we can try to find out the prediction using the coefficients. Where are the coefficients there? The coefficient is here, right? Okay. So what I will do is I will try to find a prediction here. Suppose you are having this age, then you can find out the prediction here, right? You can use any one and then fix this here, right? So I just make it as 35. I make this as 0 here. It is 0 here, right? So prediction is 0 here in spite of this. So this is how you do the regression, logistic regression and prediction using the predicted model here. Hope you have understood how to make it in Excel. Thank you.